In this lecture, we're going to see how we can constrain our class templates with concepts. In the last lecture, we saw that we could do something like that using static asserts and type traits. But now in C++20, we can do that elegantly using concepts. And our constraints are going to be part of our type. Let's see how we can do this. And this is going to be really simple. Here is our point class we have used 1,000 times by now. And it has really nothing complicated. It has a bunch of member variables which are templated because we want this to be generic. We want this to support all kinds of crazy types, for example, integers, doubles, and we can achieve this using class templates. But we don't want this template to work for everything. We only want it to work for arithmetic types like we did using type traits and static asserts. And now we're going to be using concepts. If you don't know about concepts, please go back to the chapter where we learned about them and you're going to see everything there is to know about the syntax to use concepts. And in this case, we will just be using the requires clause attached to this template declaration here. So we are going to require for t to be an arithmetic type. It needs to be an integer or a float. If it's not anything like that, the compilation is going to fail and we're going to see a concept failure in our compiler output. One thing you should notice is that we have these t's in here. And if you remember, we had a warning at the start of this chapter that newer compilers don't like this. So we're going to take out this t here. And the compilation is going to work just fine. And we're going to see a bunch of compiler errors if we try to instantiate this template with anything that isn't arithmetic. And this is something we can achieve with concepts. Now, if you have your class split into class declaration and class definition, and by that I mean the members of your class, then you're going to need to do something a little more. Here we have our box container class. It is nothing new. It is everything we have seen so far. It is templated because we want it to work on all kinds of crazy types. And we require that the type we store in our box container be default constructible. And this is a requirement that is meaningful because we're going to be storing things in something like an array or a vector. And when we create multiple elements without specifying what we put in, we need the compiler to default construct what we store in this box container. That's why we have this requirement here. If what we store in doesn't have a default constructor, we're going to throw a compiler error, and I want you to see this. So this is our requirement, and we are putting this in using a concept. And again, notice that we don't have these t's in here because this would not work with our newer compilers. And by newer compilers, at this moment, I am using GCC 11 Clang 12 and the compiler from Microsoft 2019. So if you are using these compilers and you have these t's in here, then you're going to be in for a lot of trouble. Be careful about this. And other than this, this is really all you need to do. Notice that we can also put separate requirements on our methods. For example, for our copy constructor here, we are requiring that what we store in our box container is also copyable. And this concept is going to enforce that the type that is put in the place of t here has a copy constructor. If you want, you can search for this concept. In the C++ standard library reference, you're going to find it. And this is just going to require that we have a copy constructor. And if we don't have one, we're going to have a concept failure. Another thing I want you to know is that if our method definitions live on the outside, we have to repeat the template declaration with our concept. So we have to say requires. This is really tedious, but again, this is a requirement with newer compilers. If you don't have this in, your code is not going to work with most compilers. I think GCC may allow you to ignore the requires clause here, but to make your code work, I would recommend putting this in here because you don't want your code to work on just one compiler. We have to write our code in a ways that it works on most compilers, and that's going to make your code much more portable. So this is what we're going to do here. We're going to be repeating this requires clause all the time, and you're going to see the entire class if you visit the code on GitHub, and you're going to see me play with us in a minute when we hit Visual Studio Code. So please remember to put this in. Also, please remember to repeat this concept requirement that is attached on a single method. This is the syntax you can use to do this. And other than this, your code is really going to work really well. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is class templates with concepts. We are going to bring in our template project. So let's copy the code and put that in place here. And for this to work, we're going to steal the box container class from the type traits and static assert lecture we did before. I think we can even steal the main function here, the main file, So let's do that. We're going to put all these things in here. And we're going to overwrite the main file we have here. I think this is going to do. And now we have our code that we're going to be using as a starting point here. So let's open this up in Visual Studio Code. We're going to drag and drop here. And this is going to open our new project. Let's wait for it. We are going to have a box container class. And you see that we are using static asserts like we did in the last lecture. And another thing I want you to see is that I am using newer compilers. So let's go to my tasks, because that's where my compilers are configured. You see, I am using GCC 11, I am using Clang 12, and I am using the compiler from Microsoft. And this happens to be the latest version I can get my hands on. Any newer version you're going to get is going to be fine. So we're going to play with this here. And we're going to require that the type that our template is working on be default constructible. And this is what we did with static asserts here. So we want to use concepts to do this. The first thing we're going to do is comment out our static assert. So let's do that here. And another thing I want to do to make this code work, because it would disturb us with concepts, is to use an inside operator, stream insertion operator. So I am going to bring this in, and I can comment out all the other operators we had before. So let's go down, and we're going to comment this out. This is commented out. We can also comment this out. I am just going to leave in these definitions here because you may need them, or I can even remove them because they are just going to disturb us here. So let's go to the top and even remove the friend declaration we had on line 11. So this is going to be our code. And now we're going to constrain our class here to only store things that are default constructible. Now, to play with that, we're going to go to our search engine and search for std default constructible. I think we have a concept like this, and we can use this. So let's see, std default constructible. Let's see if we have this concept here. So we're going to go to CPP reference because this is our main source of information here. And it looks like we only have static asserts here, but we can use our static assert to set up a concept, and this is going to work without a problem. So what we're going to do, we're going to require that our T is default constructible. And to make this work, we will need to include our concepts header. So let's do that, concepts. And we're going to go to our template declaration here and put in our requirement. We're going to say requires is default constructible and specify that the T here should be default constructible. If we don't put in anything that is default constructible, we're going to get a bunch of compiler errors. And they are going to be meaningful in that we're going to have a concept failure and we know exactly what is wrong. Now, one thing you should know is that we are using newer compilers and the T here is not really going to work. So what we're going to do is remove this. We're going to remove the T here. We're going to remove the other one here. And we're going to remove this one. If it is N for your code, please remove it. And the other thing we need to do, we can also remove this one, I think. And another thing we need to do is to repeat this concept requirement in methods that are implemented on the outside of the class definition. So if we go at the end of our class definition, it is right here. Any template we have needs to be constrained. And this is really tedious, but this is what we need to do for our code to be portable. So I am just going to repeat this 1,000 times. So let's put this in. We're going to go down here and put this in. And we're going to keep doing this until we hit the end of the file here. So bear with me. here. This is not going to be long, but this is what we need to do for the code here to work as we want. So 176, we're going to keep going. We're going to go to our operator plus. We're going to do this. We're going to do our operator assignment, and I think we're done here. And let's go to the code we have in the main CPP file. And another thing you should notice is that, again, we have the T here. This is not going to bode well with our newer compilers, so we're going to remove this. And we are using static asserts here, and this is really not what we want. One thing we can do is not include type traits. We're going to include concepts, and we're going to change this to use a concept. So what we can really do is cut this out, or we can even copy this, and we're going to say requires, and we're going to put in our concept here. Okay, I think this is going to work, and we're going to just remove the static assert here, and let's do something like this. And what else? We can comment out everything we have in the main function, just to make sure that our class templates are working exactly like they should. Then we're going to hit the main function and try to use these guys here. So let's build. We're going to pass this through our GCC compiler. And we have older compilers in here. I'm going to remove them, and I am going to go to terminal, run task, and we're going to choose GCC 11 here. And we're going to see how this works out. And we have a bunch of errors. And it seems we forgot something here, so we forgot the T here. Again, you see, this is a problem with newer compilers. You have to be very careful about this. So let's build again. I just removed the T that I had on my default constructor, which is defaulted. So we're going to use GCC again. And if there is any problem, we're going to try and fix them. You see, the build is good. So this is good news. Our concepts are at least correct syntax-wise. So what we can do, we can try and play with them. So the first thing we can do, we can create a point class, for example. And if we create a point with integers and doubles, we're going to see how this works out. We can comment out what we have below, and we can comment out the box container thing here. And we're going to try these things out. Let's try to build, and we're going to try and print our points, and we're going to see what we get. Because double and int are arithmetic, the build is going to be good. And if we run, we're going to see our code run, so we can bring up a terminal window. Let's do new terminal. This is what we need to do. And we're going to clear and run Rooster. You're going to see that we have our points printed out here. But the moment we try to create a point with something that isn't arithmetic, we're going to be in for trouble. So let's try to build. We're trying to create a point with strings here, and this is not going to work. And you see that our class template is now a little bit smarter. And one good thing about concepts is that we're going to get concept failures. And these concept failures are going to tell us exactly what is wrong. You see, we have requires is arithmetic. So whatever we store in our point class needs to be arithmetic. And we're going to know exactly what is wrong. We're going to come back to the class here, and we're going to see that we put in strings which are not arithmetic, and we're going to fix this problem here. This is how concepts are good. One thing I should point out is that the compiler from Microsoft is not really good yet in terms of these errors that we see. Let's try to use that here, and I am going to show you what I mean. It's not going to tell you what is really failing. It's just going to tell you that something is wrong. And I think they will improve on this later in newer versions of the compiler. But with Clang, we're going to get a really good error, just like we did with GCC. So let's build with Clang. And we're going to have a concept failure, and it is going to say that whatever we store in our point class needs to be arithmetic. You can see that right here. And then that's going to fix your problem. If you come in here, you're going to store in things that are arithmetic. So concepts are really good. They are going to make your code self-documenting in a way. And that information is going to be part of the type. For example, if somebody comes and looks at your class, they're going to see the template declaration here, and they're going to see that the requirement is really part of your type. And this is really cool. So let's go down and play with our box container. I think we can do that. We can store in things. So the first thing we're going to do, we're going to create a box container of point of int. And then we're going to be adding in things. We're going to add in point int that we created on top here. And then we're going to add another one that we create in place. Please go back to our point class and you're going to see that we have in a default constructor and we have another constructor which is going to take two t's in here. So let's try and build this and see what we get. We can pass this through our GCC compiler because it is my favorite here. And you're going to see that the build is going to be good. We can clear and run Rooster and everything is going to work. We have 2 points in 10, 20, and 40, 50 because that's what we put in. But for example, if we go in our class and say that we don't want the default constructor, we're going to delete it. You already know how we can delete methods. And if we try to build, let's do that. We're going to use GCC. Now you're going to see that we're going to have a compilation failure because we want things stored in our box container to be default constructible. And again, this is really self-documenting. You see, we are requiring that what we store in our box container is default constructible. And if a default constructor can't be found, we're going to throw a compilation failure. And this is really part of our types. This is really, really cool. Concepts are going to make your code much easier if you are using templates a lot. Again, if we build with Clang, we're going to see the same level of self-documentation. We're going to have a concept failure. But if we use the compiler from Microsoft, this is not going to be very good in terms of documentation. And again, I hope they will fix this in newer versions of the compiler from Microsoft. Another thing I don't think I have shown you is that we can even put constraints on methods. So for example, we can come to our copy constructor here and require that what we store in our box container be copyable. And this is going to require that we have a copy constructor. Again, if you are confused about any of these concepts, you can just go to your browser and say what you need to say, std copyable. I think this is what we just said in our code. We're going to click on the link here at CPP reference and we're going to see all we need to see about our concepts here. You see, it's going to require that we have copy construction, movable, assignable. We're going to really see all the details about this concept. But the main thing is that we need a copy constructor for our copy constructor to work here, because the copy constructor is basically going in, copying from the source object, pasting into our object here. This is what we're going to do. Now, because our box container is implemented on the outside, we're going to also put this concept requirement on our definition. So all we can really do is copy this, and we're going to go down where we have our copy constructor. And you see we have that right here, and we're going to put in our requires clause to make our compiler happy. I think at this point the compiler is going to be happy. And if we go in our code in the main CPP file and try to build, I think we're going to build just fine. We're going to have a concept failure because of the deletion of our default constructor here. But if we don't delete it and default it, I think you have seen the meaning of this so far. So if we put the code in and build, we're going to use the compiler from Microsoft. Any is really going to do. You see the compiler from Microsoft is happy. The build is good. Please ignore the squiggly line here. I think it is Visual Studio Code playing games with us. But we can even use the compiler, the GCC compiler, which is our favorite. You're going to see it's going to work. And this is really working. This is really all I had to share in this lecture, showing you how you can attach concepts, constraints to your class templates. It is really simple. All you have to do is put a concept on your template declaration. You can use the requires clause, or you can use any of the methods we have seen when we learned about concepts earlier in the course. We are going to stop here in this lecture. In the next one, we're going to play with a few built-in concepts. Go ahead and finish up here and meet me there.